Hi everyone. Today we are going to discuss about the first chapter from the NCERT textbook of grade 8, that is rational numbers. So before we move on to the chapter, we'll just have a glance at the prerequisites. So from your small age you have learned a lot of number system, different kinds of number systems, right? So the very first kind of number system which we would have learned all these years is the natural numbers. What are they called? Natural numbers. So these natural numbers are actually denoted using capital N. So our system of natural numbers are nothing but the set of all numbers starting from 1, 2, 3 and so on. Right? So this is the very first number system which we had learnt. The second system is the whole number system. What is it? It is nothing but the whole number system. So how do we represent whole numbers? We represent the set of whole numbers using capital W. So capital W is nothing but the set of all natural numbers including 0. So 0, 1, 2, 3 and so on. So on the other words, whole numbers are nothing but natural numbers plus 0. Okay. So the third number system which we had come across is integers. So this is where you would have come across even negative numbers for the very first time in mathematics, right? So integers, how do you represent? You use capital Z or capital Z to represent integers, and integers are nothing but the set of both negative and positive numbers including 0. So we write it as from infinity, minus infinity to minus 3, minus 2, minus 1, then including 0, 1, 2, 3, the positive numbers come in till infinity in the positive numbers, right? So these are the basic 3 number system which we have learned so far, right? So now we are going to move into another new number system, that is our rational numbers. What is that? That is our rational numbers, and that is our topic as well. Alright, so now we'll start with the definition of what is rational numbers. So the definition of rational numbers goes like this: numbers which can be expressed in the form p by q, where p and q are integers and q is not equal to 0, is called rational numbers. So p by q means it is like a fraction, right? So any number which is of the form p by q is called a rational number. So you can see another important point over here is that p and q are integers. What do you mean by integers? It means p and q can be positive as well as negative. And can someone tell me, or can someone guess what is the reason why q is not equal to 0? Q is not equal to 0 because suppose let us take a p to be equal to some 4 and q equal to 0, then but any number cannot be divided by 0. That is not possible, right? So that is why your q should not be equal to 0. Understood? And then how do we denote our rational numbers is we denote them using the letter capital Q. So now we'll see few facts about rational numbers. So every natural number n is a rational number. How do we say so? See, any natural number n can be written in the form n by 1. Correct? The value is the same. How is that possible? Because 4 by 1 can be written as 4. 4 and 4 can be written as 4 by 1. The values are the same. right? So any natural number n is a rational number because we will be able to represent any natural number in the form p by q. But on the contrary, any rational number 1 by n cannot be a natural number. It cannot be a natural number. Why do I say so? Because if it is going to be 1 by 4, is 1 by 4 a natural number? No, because natural numbers contains only numbers from 1, 2, 3 and so on, right? There we don't have any fractions coming. So a rational number cannot be a natural number. So from this we can conclude that every natural number n is a rational number, but every rational number 1 by n need not be a natural number. The second fact which all of us must know about rational numbers is that every fraction is a rational number, but every rational number need not be a fraction. Why do we say so? See, we will take few examples of fractions like 1 by 4, 5 by 6 or even 107 by 23. So all these are fractions. These are proper fractions and improper fractions are also there. But all these are of the form p by q, where p and q are integers and q is not equal to 0. So all these fractions can be considered to be a rational number. Whereas if we are going to take few examples of rational numbers like minus 5 by 6 or 23 by minus 72. So here you see that these are rational numbers because they are of the form p by q, where p and q are integers. Integers means it could be positive numbers as well as negative numbers, and q is also not equal to 0. So they are all definitely rational numbers, but they cannot be considered as fractions because fractions is a part of a whole, right? And whole numbers are what? Just positive numbers from 0, 1 and so on. So every rational number need not be a fraction. Only positive rational numbers can be considered as fractions. The third fact about rational numbers which you must know is 0 is a rational number as it can be expressed in the form 0 by q. Here p, instead of p, the value of p is q. So they have written as 0 by q. So 0 is a rational number as it can be expressed as 0 by q, where q is any non-zero number. So q should not be 0. Other than 0, for any value of q, it could be a positive value or a negative value. Like for example 0 by 1, 0 by 2 or 0 by 53 or even 0 by minus 99. It can be positive number or negative number. That is not at all an issue. But the only condition is that your q should not be equal to 0. If that condition is okay, then 0 is also considered to be a rational number. Okay, so these are the basic 3 facts about rational numbers which you must know. So now we are all aware about what is a rational number and what are few facts about rational numbers. So now next we are going to move into the next concept, that is equivalent rational numbers. So all of us have learnt equivalent fractions, right? So it is similar to equivalent fractions only. Okay, so if p by q is a rational number, then for any number n, where n is a non-zero number, then p by q is equal to p into n by q into n. Okay, so we'll see an example of this. Suppose we are given a rational number minus 2 by 5. Then n value, let us check it for 1, 2, 3 and 4. Okay, so when you have n equal to 1, then your minus 2 by 5 is equal to minus 2 into 1 by 5 into 1, that is nothing but minus 2 by 5 again. So when your n is going to be equal to 2, then you have minus 2 by 5 equal to minus 2 into 2 by 5 into 2. This is nothing but minus 4 by 10. Correct? So the next one is when your n is going to be equal to 3. So minus 2 by 5 is equal to minus 2 into 3 divided by 5 into 3. So this is nothing but minus 6 by 15. And when your n is going to be equal to 4, then you have minus 2 by 5 to be equal to minus 2 into 4 divided by 5 into 4. So that is minus 8 by 20. Right. So now why do we say all these to be equivalent rational numbers? Because if you are going to simplify them, or if you are going to write them in the standard form, then we'll see what is going to happen. See, so what is common? 2, right? So this is nothing but 2 2s are, and this is nothing but 2 5s are. So your minus 4 by 10 is again equal to minus 2 by 5 when you are simplifying, right? Again this one is also 3 2s are 6 and 3 5s are 15. So again minus 2 by 5. So this is also minus 2 by 5 again. So for the rational number minus 2 by 5, the equivalent rational numbers are minus 4 by 10, minus 6 by 15 and minus 8 by 20. Now we will move on to the next concept, that is comparison. Comparison of rational numbers. Okay, so when we are given two rational numbers, how are we supposed to compare? That is our next topic to be seen. So now we'll consider an example, and with that example let us see what are the steps to compare two rational numbers given to us. Okay, so I'm taking this example, minus 8 by 5 and 4 by minus 9. So these are the two rational numbers given to us, and we are going to compare these two numbers. Okay, so for that let us see what are the steps. And the first step is we will have to express each of the given rational numbers with a positive denominator. So it means that there should be no negative numbers in your denominator. Okay, so minus 8 by 5, you can see already you are having only a positive denominator, so minus 8 by 5 you can leave it as such, whereas 4 by minus 9, you can see the minus sign to be in the denominator. So even if your minus sign is going to be carried over to the numerator, there is no change in the value of the rational numbers, right? So you can write it as or rewrite it as minus 4 by 9. So this is the first step. So our first step is done. So now let us see what is the second step for comparing two rational numbers. So the second step is you will have to find the LCM of the positive denominators. So we have seen in fractions lesson itself, right? You will be able to compare only like fractions. If they are unlike fractions, then how do we compare? We find the LCM, make the denominator same, and only then we compare the number. It is the same step which we are going to follow here also. So you cannot take LCM for negative numbers. That is why our first step comes into play. We will have to write the given rational numbers in a positive denominator. Okay, so now since we have converted all our negative denominators to positive denominators, it is easy and there is a possibility for us to find the LCM of the denominators without any restrictions. So now let us find the LCM of 5 and 9. So I am just using the common division method. So 5 comma 9. So 5 ones are 5 and 9 remains as such. 3 threes are 9 and again 3 ones are 3. So our LCM is nothing but 5 into 3 into 3. So 5. 3 threes are 9, 9 fives are 45. 45 is our LCM. Right, so we have found out the LCM. So now our third step, that is express each of the given rational numbers with this LCM as common denominator. Right, so now we'll be doing that. So for that, what am I going to do is my minus 8 by 5 will be equal to minus 8 into 9. Why 9? Because already we have 5. 5 into 9 will only give us 45. So it's not only the denominator which has to be multiplied, our numerator also has to be multiplied. Only then this fraction will turn to be equivalent fraction and the value will not change when we are going to compare them. Right? And similarly here we have 9 in the denominator, so we'll have to multiply by 5 because 9 fives are 45. So again minus 4 into 5 by 9 into 5. So this is 9 eights are 72. So minus into plus is minus. So minus 72 by 45 and here minus 20 by 45. So here we come to the last step. Now since both the denominators are the same, it is easy for us to compare our numerators. So minus 72 and minus 20, which is greater? Minus 20 is greater, which means minus 8 by 5 is less than 4 by minus 9. So this is how we will have to compare any two given rational numbers. So first what we do, we'll express rational numbers with a positive denominator, then find the LCM for the positive denominator, then express each of the rational numbers with this LCM which we have found as the common denominator, and then compare your numerators and see which is greater and lesser and come to a conclusion. Okay, so now we will be moving on to the next concept in rational numbers, which is also something related to comparison. So once we compare two numbers, that is just comparison. What if we are having more than two numbers, 3 or 4 numbers for comparison? At that time you can find the first smallest, second smallest, then first largest, second largest numbers, right? So when you find all those, what you will be able to do, you will be able to arrange them in ascending and descending orders, right? So that is the next concept which we are going to see. So to arrange any set of rational numbers in ascending or descending order, the steps are the same as which we had followed for comparison of two rational numbers. So we will again take an example to see this. So the set of rational numbers minus 4 by 5, comma 9 by minus 15, comma minus 2 by 3. So these are the three sets of rational numbers given to us. Now we are going to arrange them in ascending and descending order. So what is ascending order? Ascending order is nothing but small to big, right? Small number to bigger number. That is the increasing order. And descending order is nothing but big to small. That is your descending or decreasing order, right? So what is the first step which we saw? All our denominators should be positive. So I write it as minus 4 by 5 and minus 9 by 15 and minus 2 by 3. Okay, so now our denominators are all different, right? So when our denominators are different, what are we supposed to do? We are supposed to find the LCM. So 5, 15 and 3. So 3 table, 3 5s are 15, 3 1s are 3. Then again I move on to 5 table, 5 1s are 5 1s are 5 1s are. So our LCM is nothing but 3 into 5, right? 3 5s are 15. What is our LCM? 15. So now let's take the LCM. Since we have taken the LCM, what are we supposed to do? Use that LCM as the common denominator for all the three rational numbers that are given. So 5 into 3, 5 into 3. So 15 we have already got. So into 1 I'm just doing. And 3 into 5 and minus 2 into 5. So now what do we get? Minus 12 by 15, minus 9 by 15 and minus 10 by 15. So now we will have to arrange them in the ascending order, right? So I'm just writing only my numerator. See, minus 12, minus 9 and minus 10. Okay, so when I'm going to compare this, what am I going to get first? Which is my smallest number? In negative numbers, the bigger numbers are the smallest number, right? So minus 12 will be there first. So minus 12 by 15 and then minus 10 by 15 and then minus 9 by 15, right? So this is nothing but, if we are going to write the original set of rational numbers given to us, then it is nothing but minus 4 by 5 comma minus 2 by 3 comma 9 by minus 15. So the same thing we have to do for descending order. So since we have written the ascending order, it is the reverse order, right? So I can directly write it as 9 by minus 15 comma minus 2 by 3 comma minus 4 by 5. So we are done with ascending and descending orders. Okay, so now the next concept is representing rational numbers on a number line. Okay, so this is the last concept for this video. So let us just quickly go through how to represent a rational number on a number line. So there are two cases of representing rational numbers on a number line. So first we'll start with case 1, where we are going to represent a rational number p by q on the number line such that your p value is always less than q. Okay, so we'll take an example. Represent the rational numbers 2 by 5 on a number line. Okay, so now I'm just going to draw a number line. Okay, so I'm drawing a straight line. So the numbers which I'm going to mark is let me consider from 0. Okay, so let this point be 0 and let this point be 2. Okay, so now I have to represent 2 by 5. So here I have 1. Okay, so now 2 by 5. What does 2 by 5 represent? 2 by 5 actually represents 2 parts out of 5. Right? It represents 2 parts out of 5. So now what I'm going to do is I'm going to divide this distance from 0 to 1 into 5 equal parts. 5 equal parts. Okay, so this first one would be 1 by 5. My second representation would be 2 by 5. So this point over here, I mark this point as point A. This is representing my 2 by 5. Okay, so now this is case 1, right? So let's move on to case 2. My P by Q is going to be such a way that my P is greater than Q. Okay, so I'm going to take the example 14 by 3. So this is an improper fraction, right? So what I'm going to do first is I'm going to convert this improper fraction to a mixed fraction. So 14 divided by 3. 3 fours are 12 and you get a remainder 2. So 14 by 3 can be represented as 2 by 3. Okay, so here 4 is nothing but the whole number. So on the number line, when you're going to draw the number line and mark it, you definitely know your number is going to be something greater than 4. So you mark it as 0, 1, 2, 3, 4 and 5. Okay, so 4 is already there, right? So we start from 0 and take full 4 units and we divide the unit length between 4 and 5. We are having 4 and 5, right? So this length alone we are going to divide it into 3 parts because we have got 2 by 3. So it's 2 parts out of 3, right? So divide it into 3 parts. So this is the first part, second part and the third part. So 2 by 3 means your second part, right? So this line, this will represent your 2 by 3. So this is nothing but your 4 2 by 3, or in the other words, that is nothing but your 14 by 3. So this is how you will have to represent an improper fraction. So case 1 is proper fraction and case 2 is improper fraction. So in other words, when you have a rational number which is of the form of a proper fraction, then you will use case 1, and if it is going to be improper, that is your rational number is going to represent a number which is similar to an improper fraction, then you will have to use the case 2. Okay, so we'll be wrapping up with this topic for today and we'll meet up soon. Please don't forget to subscribe our channel and click on the bell button so that you get notification about our future videos, and do share about our channel to your friends so that they also get some knowledge and it is going to help them to crack their math.